Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I'm available for code reviews and on-site training. In this episode, we get to cover our second ever C++ 23 feature. And we're going to be able to demonstrate this here in Compiler Explorer because GCC has just implemented it in GCC 11. And this is an update to lambdas and what syntax is allowed. All right, so currently in C++ 20, if you've got a lambda and you want it to be mutable, this syntax is not allowed. Parameter declaration before lambda declaration specifiers only optional with C++ 2b. So let's just go ahead and take this back a couple of revs so we can see the error that you're likely to see. Error expected open brace before mutable, and that doesn't really tell you what you need to know. What it's telling you is that you have to explicitly give a list of function parameters to your lambda if you're before C++ 23 mode. Now, making this lambda mutable doesn't make a whole lot of sense. But if we actually do something in the body of this lambda, like this, then each time we call this lambda, it's going to return the next incremented value. It'll return 1 or 2 or 3 or whatever. That's what mutable is going to allow us to do. It's going to let us mutate this capture here. But this empty parameter list is slightly annoying. And now it is required only in the case of if you have some other decorator or something between the capture and the body of the lambda. So getting back to here, if we were to upgrade our compiler back to GCC 11 and put this in C++ 2a mode, then I guess, or 2b mode, 2a would have been C++ 20, 2b mode is C++ 23, then we're allowed to do this. And, you know, this lets us slightly simplify our version of Fibonacci that I've used on this channel before, where if I've got this version, let's see, and I want to do and we should see this incrementing up in the Fibonacci sequence. We're going to get 5 the next time we call this, etc. Or we could write a quick loop that does this. And we can see our Fibonacci sequence here being generated, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, etc. Looks correct to me. But of course, much more clean is to actually use format. We're printing this out with format, or we could do :x here to print this out in hexadecimal format. So we see 1, 1, 2, 3, 5, 8, D, 15, 22, 37. So we're seeing hexadecimal versions of these values now. All right, we've got the first n however many hexadecimal versions up here. That's all good and well, but I did promise in the last episode that we would come back around to that hello Commodore thing. Now my Commodore code definitely did not want to feel left out here. So I can do this exact same algorithm of the Fibonacci with the mutable here and leaving out the open parens. And I can pass this to a get put hex function. I'm also doing a clear screen ahead of time here. Ignore these clock things that are above this line of code. That doesn't have any relevance in today's example, but it's for some other project that I'm working on. And I can do this, put hex at x of 30, y from 0 to 25. This should output the first 25 Fibonacci numbers in hexadecimal. Now you may note that I have not yet actually cleaned up this tool, so it still takes an awful lot of knowing what you're doing to pipe it through all of the different things. But there we go, 1, 1, 2, 3, 5, 8, D, 15, 22, 37, 59, 90, E9, 179, E9, 179, 262. It looks like we did the correct thing, both in the Commodore version and in the Compiler Explorer version. For the fun of it, printing out the list of the first 25 hexadecimal numbers in the Fibonacci sequence. Now, I'm sure some of you are going to be curious, so let's just go ahead and look real quick. It looks like this is a 553 byte program. Now keep in mind, that is the entire program. There are no other libraries that it's linking. There is nothing in the Commodore that it's actually relying on in its ROMs. It is actually doing all of those hex conversions from the binary values and calculating the Fibonacci sequence and writing it all out in the 25 lines and doing the loop in 553 bytes. And I know that it still has inefficiencies in it that any of you 6502 experts who are watching this will note. So, but it's fun. So hopefully we get to play with this some more. And thank you for sticking around for this episode of C++ Weekly. I hope you enjoyed it. Be sure to subscribe. See you in the next episode.